So, continuing our topic on the MTP2 layer, let us continue the concept of signaling unit. Signaling unit is nothing but a packet, a piece of information which is being sent over the link. Okay, so on the MTP2 layer, a packet is sent over the MTP2 layer in the form of these signaling units. And there are typically three types of signaling units supported by MTP2 layer. One is the message signaling unit called MSU. Okay. So basically there are three kinds of signaling units. One is called MSU, the message signaling unit. These units are basically the main payload which is coming from the higher layer and that is being sent on the MTP2 layer. Okay. Second type of signaling units are LSSU. LS here means the link status. Okay, this kind of packet is not coming from the higher level. This is generated by the MTP2 layer itself to perform the link status related activities. Okay, so suppose on the link, one entity wants to inform the other entity that the link is busy, or the MTP2 layer is busy right now, or there is congestion. Then that status will be communicated on using this packet to the other end, and this will not percolate throughout the network. It is just between one endpoint to another endpoint, and that's it. So it does not percolate to other elements of the network. So that's the link status signaling unit. And then the third is the FSSU. FSSU. That's called FI here is the fill-in signaling unit. Okay. So notoriously this is called as MSU, LSSU, and FSSU. Okay. What is FSSU? FSSU is basically when there is nothing to be transmitted over a link, over a MTP2 link, then these are kind of filler packets which are sent periodically over the link to maintain the sanity of the link. So these are called the FSSU packets. Okay, so we have MSU, LSSU, and FSSU. LSSU and FSSU, they are basically generated by the MTP2 layer itself. MSU is generated by the top layer. Okay, so MSU is the main packet, the main payload which is to be transmitted on MTP2 layer. Now, the important thing to note here is that since MSU is the real traffic which is being transmitted, so if there is any error in transmitting this packet, then it will be retransmitted and kept in the retransmission buffer. Whereas if there is any error in transmitting LSSU and FSSU, they are not retransmitted. Okay, because they are generated by the MTP2 layer itself, and periodically based on the link status, they are automatically generated. So there is no retransmission of LSSU and FSSU, and the error transmission, error recovery, everything, all those things exist for MSU only. Okay, so let us take the format of these three kinds of messages. Okay, so the first one is the MSU, message signaling unit. So let us dissect this message. Okay, so the first part of the field is the filler. This is 8-bit filler, and as we studied, it is a standard flag. This. Okay. So this is used to distinguish between two adjacent packets. Okay, so that's a fill-in packet, fill-in information between two packets, just to segregate one from the another. Then comes 7-bit information about BSN. This is a backward sequencing number. This is 7-bit information. It is basically used to send back the sequence number in the backward direction. Okay, so more we'll understand on BSN when we cover the flow control provided by the MTP2 layer. Then there is a BIB field. This is 1 bit, and this is a flag which is used to indicate the acknowledgement of the packet in the backward direction. This also we'll understand when we cover the flow control. Then comes the FSN, the forward sequence number. This is also 7-bit, and this is used for flow control in the forward direction. So just like BSN, FSN is in the forward direction, BSN is in the backward direction. Then corresponding to FSN, there is a flag also, which is forward information bit, which is used to provide the acknowledgement of the packet in the forward direction. So don't worry if you don't know about all these terms, BSN, FSN, BIB, FIB, they'll be covered in detail in the flow control part of MTP2. Okay, then the next is the length information. This is a 6-bit information. So 2 to the power 6, that is the total length that can be represented by this. Okay, then there is a 2-bit spare information. This is a spare bit generally filled with zeros, and then there is service information octet, which is 8-bit in size. Now this service information octet, it is basically, it signifies the user part which is going to consume the main information of this MSU. As we all know, MSU is the signaling unit containing the main payload coming from the higher user parts like TUP, ISUP, DUP, etc. So that message, it belongs to exactly which user part. That information is encoded in the signaling, in the service information octet. And then after that there is SIS, service information. And for MSU, this information is more than 6. And finally, the check bits, which is a 16-bit CRC. This is for error checking and error recovery. Now this SIS, this is the main payload, which is coming from the higher user part. So once again, let us recapitulate. The F here is the flag for segregating the packet. BSN is the backward sequence number, which is used for tracking, providing the sequence number for the traffic in the backward direction. Then there is a backward information bit, which is used for providing the retransmission or acknowledgement related information for that particular sequence number. Then there is a forward sequence number, which is essentially the sequence number information for the forward traffic. Then there is forward information bit, which is nothing but the acknowledgement bit for the traffic in the forward direction, forward indicator. Then there is LI, length information. Then there is SIO, which is you can say the service information or the user part related information. Then there is SIF, which is service information, sorry, signaling information, signaling info, which is basically the main payload, and then the CRC of the whole packet for error checking. Okay, so I hope that's clear. Let us move on to the next one, which is LSSU. Okay, so LSSU is the link status signaling unit. It is very similar to MSU, just that it doesn't have any signaling information part, for a simple reason that there is no signaling information which is coming from the top layer. So first is the flag. Flag is 0111 1110 for segregating the packet from the adjacent one. Then there is a BSN, which is the backward sequence unit along with backward indicator. Then there is FSN, which is the forward sequence number along with forward indicator. Then there is length information, which is 6 bits in size. And there is a 2-bit spare. The spare bit is generally filled with 0, 0. Then there is a status information, which is 8 or 16-bit in size. And then there is a CRC, which is 16-bit in size. Now this field here is not the signaling information, it is a status flag, which basically means the status of link status in the payload. Okay, and rest all the fields, they are common with MSU, so I'm not going again into all those details. Okay, so let's cover the FSSU also. So fill in service signaling unit is basically a filler information on idle links. This has basically all the essential parts of MTP2 layer messages are there. First is the flag. Flag is 0111 1110. Then there is a BSN with backward indicator. There is FSN with the forward indicator. Then there is a length information, which is 6-bit in size, and there is 2 bits of spare, and finally CRC, 16-bit. As you know, this is an empty packet. It doesn't have any information. It's just a filler packet, so there is nothing in this packet like status or signaling information. Practically nothing is there. Okay. So rest all the fields, they are common with other with MSU and LSSU. So I'm not going deep into that. So just if you compare these 3 packets together, then you will find that the only way in which you can distinguish between these packets is based on the length information. Okay. Based on the length indicator. How? Let's see. So basically, if it is a FSSU, for FSSU, this length indicator is going to have value 0 because practically there is no payload. If it is LSSU, then this length indicator is going to contain 1 or 2. Okay, that's precisely either 8 bits or 16 bits. But if it is MSU, then length information is going to be greater than or equal to 3. That is, there will be a lot of information in the MSU. So precisely based on just the length indicator, these packets are distinguished and accordingly they are handled. Okay. Now we'll understand all the procedures which are available, which are made available to us by the MTP2 layer.